The purpose of numeric elements is to handle numbers. They can be represented graphically in many different ways. After placing element on the panel, start typing to give it a name. Proper labeling justifies element's purpose. Then you can change various properties. For example, set value limits, increment step, and many others. The property you will change most often is representation. You can choose a floating point number to have single, double, or extended precision. Double is most common. Integers can be signed or unsigned and have ranges from 8 to 64-bit. Complex numbers are basically two floating point numbers with a certain precision. This one here is a fixed point number, which we'll discuss on another occasion. In the diagram, you can distinguish both representations by color. Floating point is orange and integer is blue. These different representations have their own purpose. Integer numbers are often the core of an application or algorithm development. They keep the functionality in place, while floating point numbers are usually a result that needs to be calculated. Integers can be used with logical functions, connected to a case structure, represent an error code, or represent an enum. We have a lot of functions for operating on numeric values. Most of them are obvious. For others, a context help window will come in handy. You can manipulate integers by shifting bits. You can split and join numbers. This is useful in FPGA applications. You can change the representation of the numeric by using those functions here. Numeric functions are polymorphic, meaning they will adapt to the type they are using. You will quickly discover you can easily mix orange and blue, and it works fine. The coercion dot notifies you that the function has to adjust the types, which consumes additional memory and a time of memory manager. Coercion dots have also a deeper meaning. When your types don't match, it may indicate that your algorithm assumptions or understanding of the program is not proper. An additional effort towards removing coercion dots may increase program performance, but also will increase your understanding of the problem you're solving. You can always adjust the types by changing the origin, or by using these functions here. In general, when you see a coercion dot here, consider whether the program needs improvement. Good to know. The palette contains math constants that you can use for calculations. A floating point value can be not a number or infinity, but remember that they can significantly change the result. Notice that a not a number value here is not visible on the graph. Dividing integers this way indicates type mismatch as it operates on floating point numbers and returns such. You might want to use this instead, where you get an integer with a reminder. Two floating point numbers shouldn't be equal. In range and coerce is helpful. A timestamp is another form of a double precision floating point number. This is useful while building timers.